Now that we know how to build an equation, now that we know how to read the different parts of a slope-intercept equation, how to find an x-intercept or y-intercept from an equation, is it horizontal or vertical? Now I'd like to basically flip the roles, and we're going to be given a graph and we need to match it up to the correct equation. So first thing I'd like to mention is if you have an equation that's not in slope-intercept form, um, my personal preference would be that you flip it over to slope-intercept form, so that way you can check for the y-intercept of that line on the graph. You know, does it match up to the y-intercept? That'd be the first thing I look for. And then if it does, then I would go and check the slope to see if it matches up. And if it is, you've got the graph matched up to the equation. Um, Other people, though, you know, they may prefer you to use like plug in an x value and see if you get the same y value into the equation, and that's just the way that we check to see if a point was on the line. That's fine, but for me, I use the slope-intercept method. So let's look at some equations that could be given to you. Here in the first one, let's say you were given 2x plus y. That's in the standard form, so we would just subtract 2x. It would cancel the 2x's out here, and we'd be left with y all by itself. And then I always like to put the x's in front, the x terms in front, so that way I could get my slope, and it'd be negative 2x plus 4. So my slope would be negative 2, and my y-intercept would be positive 4. Then when I come down here and take a look at my graphs, you know, I'm checking for my y-intercept first, but we'll get to that. Let's look at number 2. You'll notice this one, it's an odd equation because there's no x on there. That's because it's going to be a horizontal line. When you see y equals a number, it's horizontal. Same thing if you see x equals a number, that'll be a vertical line. Um, Number 3, we actually have a slope intercept. What if there's no number in front of the x? Well, in that case, it's a 1, so our slope is positive 1. This is a plus 2 after that, so my y-intercept is 2. And number 4, negative 1/2 x equals y. Well, my y is by itself. You might want to flip the sides just so it's a little easier to see it's in slope-intercept. Negative 1/2 x with no y-intercept shown, but that means your y-intercept is 0 and my slope is negative 1/2. So now we just go down and we'll take a look at these uh, graphs of the lines and we'll see if we can match them up. Now, right here on, well, I'll tell you what, let's actually just flip these around real quick. Sorry, I didn't mean for it to be out of order. But let's just say this is graph A. You'll notice that it crosses at positive 2 on the y-intercept, so I'm just literally marking it b equals 2. That way I know it's the y-intercept. And what's my slope? I go up 1 to the right 1, up 1 to the right 1. So my slope is positive 1. Let's go up here and find where my slope is positive 1. Oh, right here, see, number 3. And my y-intercept was 2. Yeah, slope is 1, y-intercept is 2. So, yes, A is my graph, and that's the reason I have A right there. You could go through this on each one. For example, look at this one right here. My y-intercept is 0. Well, there's my y-intercept at 0, and I would go down 1 to the right 2. So my rise is negative 1 and my run is positive 2. There's my slope, and it matches up. Number 2, we're saying it matches up with graph C. Here's a horizontal line that's crossing at positive 4. Yeah, that's y equals 4. So that's C. And then number 1, y equals negative 2x plus 4. It's a negative 2 slope with a positive 4 y-intercept. Here's the positive 4 y-intercept, the negative 2 slope. I go down 2 and to the right 1. Down 2 and to the right 1. And that's all you really have to do to be able to identify a graph of linear equation. If you can get by with your horizontal and vertical lines, then just flip all of your other equations into slope-intercept and use that data, the y-intercept and the slope, to match it up.